Here we are again. Hello everyone. In the upcoming video, I will show you a repair of an air conditioner circuit board, meaning that the fault diagnosis is easy because it is visible. The integrated circuit here we see is cracked along with a resistor. It is easy to diagnose because I don't even need to measure to see what the problem is. But I will show you how I found. Which integrated circuit will I use? Here you see I have placed a Greek K364. But why did I end up choosing this integrated circuit? If we observe closely the integrated circuit that had failed, we will notice that on one side it has 4 pins on the left, and on the right it has 3 pins with a gap in the middle. These types of integrated circuits empirically fall into 2 categories. They start with the initials EY and the Greek letter K. These integrated circuits are used in power supplies. Specifically, they are MOSFET integrated circuits. Now let's show you on the circuit how to identify which integrated circuit it is and which one we will ultimately use. So it's a classic old power supply. I'll try to sketch some of the details that aren't visible so you can understand how it works. Right here is the 220V rectifier bridge. I will mark it here with 1 or 2 marks, so we remember that here at the TVs, and to the left, they are rectified. Here is the positive, and here is the negative, the rectified voltage. And here is the smoothing capacitor. Here goes the line that we see, leads to 2 chokes. The 2 pins we're working with here, one of them is a choke, and here is the 220V input. I will write AC here. That 220V is input here. Here you connect to the 2 little legs. It passes the filter. Where we work on it, it goes in series. This resistor here, which was burnt, and this one I showed you before. It passes through the bridge. You rectify. The positive goes to the smoothing capacitor and continues, passes along this line. Here is the transformer. It passes through the transformer's primary winding, which I will draw here. Here we are at the primary of the transformer. And goes to pin 5 of the integrated circuit. And then at pins 7 and 8, it leaves and goes back to the other side of the capacitor. So we understand that at 5, pins 7 and 8 are the MOSFET. To see what else we notice here now, let me zoom in the image a bit. You can see here that pins 7 and 8, as well as 1 and 2, are all shorted together. So here is my MOSFET. One leg of the MOSFET is here. The other leg of the MOSFET is at 1, 2, 7, 8, and 5. And at 3 and 4, from what I see here, it goes to the coupler to take the feedback from the transformer output. Here is the transformer. It is powered from above and below. Down here is the transformer's output, which is rectified by the diode here and sends feedback back through the coupler. So in summary, we are looking for a primary winding that is short-circuited by the pins 1, 2, 7, and 8. At pin 5 should be the MOSFET. And pins 3 and 4 go to the optocoupler. And the optocoupler appears. So let's go to Google to search now for the pinouts of different switched mode power supplies. We first search for the TNY. To type TNY pinout, it will show me here. Some other switched mode TNYs, we will notice that their right side is all connected here on the TNYs. At 177 and 277, their right side is all short-circuited all the MOSFETs. At 177, so we see that the gap is on the other side, the opposite side that we need. So it goes 1, 2, gap 4. while we needed 1, 2, 4, 4, 5 spaces, 6, 7, 8. So it's reversed. So TNY is not what we're looking for, the target. Let's check out the Greek APA now. We will write here Greek APA table. Let's see if it matches the little legs. We observe here that the very first determines for us what we want. 8, 7 short-circuited that we see here. At position 5, from what I see, it is the second part of it. And we go to the sales manual of the specific device. This is the Greek from 302 to 306. However, we observe here in the design that it has not been mesmused. It uses a simple coil and rectifier at its output, which is for low power. That is, it does not have high power and does not use mesmusty. Primary secondary, meaning it does not have high power and we do not use a transformer. Primary secondary, meaning the secondary does not provide feedback either. The coupler to provide for its input to regulate voltage. And if we observe here the circuits it provides, the manual, in none of them, we use couplers and the coupler, so it doesn't suit us, not even self-logged. We will switch to another type. The LNK suits us, but the 300-306 series does not. So we will now go to the LNK 362-364 series. We will see here again number 362. Up to 364, and now we observe here that here they have also mentioned the mathematician and feedback mixing through the coupler that we see here in its circuit. And the pins are correct. So we could use this precedent. That's why I chose this timed example, the 364. Why I chose 364 and 362. Why I chose 364 and 362. It appears here in its features. It appears here in its features that the only difference they have, the higher the number, the more watts it represents. So they have more powerful ones. The 364 is stronger. So I will use the 364, which will definitely withstand the watts, the power required, and everything else needed. Now, we're looking inside the circuit here, that it is exactly the same as what we copied from the board. With the rectification, the integrated circuit here, as seen, equal to the base resistor and the feedback from the coupler. From what I tested, I naturally put it on top. The board worked normally. It didn't have any problem. I left it for some time, and it worked. So with the NK364, we got the work done. And that was the operation, exactly like that. I chose the integrated one. So if you liked the video, you can subscribe to my channel, like. I am waiting for your comments. Thank you very much. Bye.